In the bustling heart of Hangzhou, China, where skyscrapers pierce the sky and technology pulses through every street, one of the world's largest tech companies has quietly changed the game. Alibaba, the titan of e-commerce and cloud computing, has unveiled a new method that could revolutionize artificial intelligence. A method so powerful, so efficient, that it slashes the cost of training AI for search by a staggering 88%. The world of artificial intelligence is fast-moving, competitive, and expensive. Behind every smart search result, every virtual assistant's answer, and every algorithmically curated feed lies a complex process of training massive AI models. These models are fed on huge datasets, powered by thousands of GPUs, and run through billions, sometimes trillions of parameters. The cost is astronomical. The energy demand, colossal. But now Alibaba's innovation promises a different future. One where cost is no longer the bottleneck, where smaller companies can compete, and where AI becomes not just smarter, but more sustainable. At the heart of this breakthrough is a technique called ELF. Short for Efficient Large-Scale Fine-Tuning, ELF is more than just a clever acronym. It represents a tectonic shift in how companies can approach search-based AI tasks. In the past, training a large language model for search functionality required vast resources. Developers would take a pre-trained foundation model, often based on transformer architecture, and spend weeks or even months fine-tuning it for a specific task, like e-commerce product search. This process required extensive computation, a massive corpus of labeled data, and teams of engineers. Alibaba's new method challenges that standard. With ELF, engineers are able to fine-tune pre-trained models with drastically fewer labeled examples, sometimes 100 times less than before, and using a fraction of the computational power. The result? A model that performs just as well, sometimes even better, at a fraction of the cost. But how does ELF work? To understand that, we need to dive into the traditional approach. Typically, large-scale models undergo what's called full parameter tuning. Every parameter in the model, billions of them, is adjusted based on new training data. This process is heavy, both computationally and financially. ELF, efficient large-scale fine-tuning, is Alibaba's groundbreaking approach to making AI model training faster, cheaper, and more accessible. Traditional methods of fine-tuning AI models involve adjusting billions of parameters, requiring enormous amounts of data and computational resources. This process, while effective, is slow, expensive, and environmentally taxing. ELF changes that by taking a smarter, more streamlined path. Rather than updating the entire model during training, ELF freezes the majority of the model's parameters and focuses on modifying only a small subset, known as adapters. These adapters are compact, trainable modules strategically inserted between the layers of the original model. Because they are the only components that undergo change, the training process becomes significantly more efficient. The base model remains untouched, preserving its general capabilities, while the adapters are tuned to fit specific tasks or datasets. This technique isn't entirely new. Adapter-based tuning has been explored in the academic world, primarily as a way to fine-tune large language models without the need for full retraining. However, Alibaba's real contribution lies in how they've adapted this idea for large-scale commercial applications, specifically search. Search systems, especially in e-commerce, require models that can handle massive volumes of real-time queries across diverse categories and languages. Alibaba refined adapter-based tuning by building a hybrid architecture tailored to this environment. Their version of ELF optimizes the adapters to efficiently respond to high-frequency search terms, seasonal trends, and multilingual demands, ensuring that the system remains accurate, responsive, and up-to-date without requiring constant retraining of the entire model. The results are impressive. By using ELF, Alibaba reported an 88% reduction in the cost of training AI models for search tasks while maintaining nearly identical performance levels. That means models can be trained more quickly, deployed faster, and fine-tuned more frequently, all at a fraction of the typical expense. Importantly, ELF has proven its ability to scale. Whether it's a model handling a few thousand queries or serving hundreds of millions of users daily, the approach holds up. This breakthrough is not just about saving money, it's about making cutting-edge AI more sustainable and widely accessible. Smaller companies and research institutions, which previously couldn't afford the high costs of fine-tuning, can now build powerful, customized models using fewer resources. It also opens the door to more frequent model updates, allowing AI systems to stay current with changing user behavior and trends. In a world where AI's capabilities are advancing at lightning speed, ELF offers a thoughtful, efficient alternative to brute force scaling. By focusing on smart design rather than sheer size, Alibaba has laid the groundwork for a more inclusive and energy-efficient future in AI development. In internal benchmarks, Alibaba cloud engineers found that models trained using ELF retain 99.7% of the original model's performance, while reducing compute costs by 88%. That means more than just saving money. It means dramatically reducing the carbon footprint of AI training. In the age of climate anxiety, that matters. Dr. Lin Yao, a lead researcher at Alibaba Damo Academy, explains, AI is moving fast, but the environmental cost is catching up with us. With ALF, we're making AI not just smarter and cheaper, but greener. That's essential if we want AI to scale responsibly. And scale it does. Alibaba has already deployed ELF-tuned models across its Taobao and Tmall platforms, powering search results for hundreds of millions of users daily. Customers searching for summer dress, wireless headphones, or organic green tea are now being served results by models trained in hours, not weeks. The impact is immediate and measurable. Faster response times, lower latency, more personalized results, and most importantly, significant savings. This democratization of training costs opens up new doors. Suddenly, startups, academic labs, and smaller e-commerce platforms can train their own search models without breaking the bank. A task that once required a multi-million-dollar cloud budget can now be done with a few $1,000s, and in some cases, even less. Industry experts are already paying attention. Jared Kaplan, a prominent AI researcher in the US, commented, "What Alibaba has done with LF is signal a new phase of AI development where efficiency becomes the core metric, not just performance. This is essential if we're to keep pushing the envelope of what AI can do without burning through the planet's resources." And it's not just in China. Alibaba Cloud has made ELF available to external partners through its Model Studio platform, inviting developers worldwide to integrate the method into their own pipelines. Early adopters in Southeast Asia and the Middle East are already reporting up to 70% faster go-to-market timelines for new AI products. The timing couldn't be better. As generative AI sweeps across industries, the demand for fine-tuned models is skyrocketing. Every bank, hospital, and retailer wants an AI that understands their data, speaks their language, and aligns with their customers. But until now, only tech giants could afford that kind of customization. With ELF, that exclusivity is breaking down. There are, of course, questions. Can the same approach be applied to multimodal models, those that handle images and text simultaneously? How does ELF perform with noisy or sparse data, where traditional fine-tuning struggles? Can adapter-based tuning keep up with the increasing complexity of LLMs as they grow into the trillion-parameter scale? Alibaba's engineers believe it can, and they're already testing the next evolution, called ELF++, which integrates sparse expert routing and contrastive alignment to push the envelope further. The broader implication is this: the future of AI may not belong solely to the biggest, fastest models, but to the smartest methods of tuning them. Efficiency, not brute force, will define the next generation of breakthroughs. In many ways, it's a return to form. In the early days of AI, progress was often measured not by scale, but by ingenuity, by the cleverness of algorithms, the elegance of mathematical models. With ELF, we're seeing that spirit again. A spirit of doing more with less. Back in Hangzhou, the engineers behind this shift are quietly optimistic. They know the world of AI won't stop growing, but they believe it can grow smarter. As one Alibaba scientist put it, innovation isn't just about building bigger models. Sometimes it's about asking better questions. Do we need to train everything from scratch? Do we need millions of examples? Or can we, with a little math, and a lot of insight, find a better path? The answer, it seems, is yes. From inside the server rooms of Hangzhou to startups in Nairobi, Mumbai, and São Paulo, that better path is now within reach. Thanks to ELF, the cost of innovation just got a whole lot lower. And the future of AI, more open, more efficient, and more sustainable, just came one step closer.